EA is less than a threshold. Okay, we call it ES, percentage. Okay, this is called a threshold. Okay, which we can set, or in some cases I call it error tolerance. Okay, now I can set it. Let's say I set EA less than 5%. So run the numerical method when EA becomes less than 5%. Okay, this is doable, easy, because I will compute EA all the time. Okay, when EA is less than 5%, I will compute. Okay, one more thing, I can say that, let's say I want more precise answer. Okay, then what I need is I will make the threshold very small. Like I will say stop or run the numerical method till EA is less than 0.0001%. In this case, this threshold will be very strict because I want a very precise answer. Okay. One more thing, that ES is also related to number of significant figures. Okay, there is one formula that relates it to them. Okay, this formula is that 0.5 into 10 raised to power 2 minus n%. You can set the number of significant figures here. Here n is significant figures. Okay, so you can set number of significant figures and you can get this threshold value automatically, or error tolerance value automatically. So let's say I want to set n equal 3. I want my result up to 3 significant figures. So you can get what should be the value of ES. So in this case, 0.5 into 10 raised to power 2 minus 3%. So this means 0.5 into 10 raised to power minus 1%. Okay, this means ES should be equal to 0.05%. Okay, so this is the value of ES, and I have to achieve EA less than this 0.05% to have 3 significant figures. Okay, so this formula relates significant figures and ES. Okay, otherwise, if I don't worry about the number of significant figures, as I told you, I can set it to any number like 0.001, 0.005, okay, 0.02, okay, or 2%, 5%, depending on the precision I want. Okay, so this is in my control, ES. Okay, but sometimes we relate it to number of significant figures. When we relate it to them, then of course this formula will be in the picture, and then I use this formula to compute the error tolerance here, 0.05% in this case for n equal 3. Okay, so let us solve an example which relates, or which discuss every aspect of what we have discussed so far. So here the example is basically this is all what we have discussed. Okay, now it wants us to compute e raised to power 0.5. Okay, now this is called exponential of 0.5. Okay, we know that exponential is 2.718, and we use a simple calculator to compute these. We need to compute these we can use calculator to compute these values like e raised to power 0.5. Okay, because there is a function in our calculators, okay, which can compute it. So what I did, I computed it. Okay, and it turned out to be 1.648721. Okay, now this value will be treated as the true value, because this is what I have been using all the time in all my calculations. Okay, so the value written here will be now used as the true value 1.648721. Now it's asked us to compute e raised to power 0.5 up to 3 significant figures, and during the calculation process compute the true and approximate percentage relative errors at each step. Okay. Now what is the other way of computing e raised to power 0.5? Okay, I learned that there is a series series can compute e raised to power x. Okay, from math book. Okay, now it says that it is an unlimited series. So what we have to do is we have to do additions of these terms. Okay, the first term is 1, then plus x squared by 2 plus x cubed by 3 factorial. This sign is factorial sign. Up to this series never ends, and this is the nth term. Okay, maybe n equal 100, so this will be x raised to power 100 divided by 100 factorial. But generally this series doesn't end. Okay. Now up to 3 significant means what we have to do is we have to compute when approximate error is less than a certain threshold. We are going to get it. Okay, so let us compute this e raised to power 0.5 using this series. Okay, and let us see what does we get. Okay, so again we go to our paper sheet and discuss it. Okay, by the way, we will be using these two formulas, okay, which I will be referring to many times in this discussion. Okay, so now I'm going to write whatever was given in the question. Okay, first thing which I remember that it is the formula which is basically compute e raised to power x. Okay, so e raised to power x can be computed as 1 plus x squared by 2 plus x cubed by 3 factorial plus x4 by 4 factorial plus x5 by 5 factorial, and the series never ends. This is the main point, that this series never ends, and I will keep on computing these numbers e raised to power x. Okay. Then the other thing was that e raised to power 0.5 was computed and given to me using the calculator, and this one is the numerical value which is given to me, and I assume this is the exact value, so we call it the true value. So true value is given, e raised to power x is given, and one more thing is given. I have to compute up to 3 significant figures. Okay, so in this case I know that n equal 3, and this will help me to compute the threshold or the error tolerance. So this one is 0.5 times 10 raised to power 2 minus n percentage. This is the formula which links the number of significant figures to the error threshold. Okay, so I have n equal 3. So in this case this will be this will percentage will come here. Okay, and so I want to have EA is less than 0.05%. So the stop when EA is less than this error threshold, this is 0.05%. Okay, so let us do it. But basically, how do we compute e raised to power 0.5? We will use a we call it very lazy approach. Okay, and based on basically numerical methods. Always use this kind of lazy approach. The laziest approach is I don't want to add 100 terms or maybe these 5 terms and then compute the approximation EA later or ET later. I don't want to waste my calculation. So what if I just take the first term and call it e raised to power 0.5 is approximation. So this is the sign for approximation is equal to 1, because my approximation is based on the first term. Now what I want is that this is my approximation. I want to compute ET for this one, for this approximation, ET percentage, this means percentage relative true error. And I also want to compute EA. Maybe I come to know that EA is already less than 0.05, so why waste my calculations, okay? That's why I call it the easiest, the laziest approach. That we will go like this, we will take the things term by term, and then we compute the ET, we compute the EA. The moment EA is less than this threshold, we will stop. So let us compute. Now we have the approximation. Okay, for our first approximation based on this series, which is only term number 1 of this series. E raised to 0.5 is 1. I want to compute this true error. Okay, now I have to look at the formula and then I have to see what values are given. Okay, and based on the formula, I should ask myself, can I compute this number right now or not? Okay, so let us go back to the formula. The formula was this one, true value minus approximation over true value. So now I ask this simple question, do we have the true value in this case? Okay, yes, true value is given. Do we have the approximation in this case? Yes, I just computed it. So this means I can apply the formula here, which is true value, okay, 1.648721 minus the approximation, which is 1. So the true value minus approximation over the true value, and this is what the formula says that, okay. And then I have to multiply with 100 so that I get a percentage value. So now if you have a calculator, you can compute it. Otherwise, I'm going to compute it with my calculator. So 1.648721 minus 1, which is the difference between the true value and the approximation, divided by the true value. Okay, I am applying this formula, true value minus approximation over true value, and then multiplying with 100%. Okay, I get an error of 39.3%. Okay. Why is that? Why true error is this much, 39%? Because of the simple reason, my approximation, if I look at the numerical value of approximation, which is 1, I look at the true value, which is 1.648721. I can see that 1 is far from the true value, which means 1 is far from the target. How much I am far from the target? In relative sense, 39.3%. Okay, so this tells you how far you are from the target, right? So this computes your accuracy, that you are far from the target by 39.3%. Now I want to compute this EA. Okay, again, I use the same concept, that I will look at the definition of EA percentage, and then I will ask myself, what do we have and can we compute it at this time or not? Okay. So look here, EA percentage needs this computation. It needs current approximation minus previous approximation over current approximation. Okay, so it needs two approximation. One is current, the latest one. One is the previous one, and divide by the current one, okay, to make it percentage relative error. Multiply with 100% to make it percentage error. Okay, now I look here. How many approximations do I have? In my table, I have only one approximation, which is called the latest one. The current approximation is this available to me. Do we have any previous approximations so that I can apply the formula? So I have current approximation. Formula says you need to have two approximations, current approximation minus previous approximation. So do we have previous approximation? Current one I have. What do you think? If yes, if there is previous approximation, what is that? Anyone? Any guess? 0.5? No, we have value of x is 0.5 and we have to compute e raised to power 0.5. So 0.5 is not the previous approximation. So the question is very simple. I want to apply a formula which is based on simple difference of two approximations. One is called current approximation, one is called previous approximation. Okay, I have one of approximations, okay, which is written here, which is, I call it current approximation. So now the question is, do we have a previous approximation at this step? So do we have a previous approximation? Anyone can, any guess, any other guess? 0.5 was not a good guess. Okay, any other thing? Okay, the question is, did we run the numerical method before? Okay, or this is the first time? Which term is that? This is the first term, right? First term gives me only one approximation, right? I never run this step earlier. Okay, this means I never had my previous approximation. So I have current approximation, but I don't have previous approximation. So this means I cannot compute this error, not at all. Right now, I cannot compute it. This error can be computed only if I have two approximations. One will be called current approximation and one will be called previous one. Okay. So currently I cannot compute it, so I should continue and do another approximation. Okay. The idea is same, that take another term now. Instead of taking 4 terms and then do it turn by turn. Take another term and approximate it. So 1 plus x is now the new approximation. So now I use the approximation sign. I am using 2 terms. Now you can see that I have a new approximation, and in this case the new approximation with a numerical value of 1.5. Okay. Now again I asked you the same question. Can I compute the true error? Okay. I go to the definition and look what is needed to compute the true error. I need the true value, I need the approximation, divide by the true value, multiply by 100. This is all I need. Okay, and this is what is given here also. So true value is given 1.648721. Approximation is 1.5 divided by 1.648721. Okay, multiply with 100%. Okay. This way I will get the true error. Okay, I computed it. Okay, I got like 9 point. Okay, let me copy it. I got it 9.02%. Okay. Now the question is, has the error, true error, has the error decreased? If yes, why? Okay, I can see from here 39.3% with approximation, first approximation. The second approximation with 1.5, I got an error of 9.02%. Definitely it has decreased. Okay, why it has decreased? Can somebody comment on that? Why this error has decreased? Anyone, why this error has decreased? Before it was 39%, now it is 9.02%. Why it has decreased? What is the reason? Can I say that reason? Okay, idea is to look at the true value and the approximation you have. Okay, the approximation is 1.5, the true value is 1.648. Before the approximation was 1. So you remember that what this is computing. ET is computing how far you are from the target. Target means the true value. So when I was using 1 as approximation, I was very far from the target. But now I am using 1.5, okay, as the approximation, and this value is not that much far from the target. Okay, so that's why the error decreases from 39.3 to 9.02%. So this means I am approaching the target. The good thing is if the error is decreasing, I am approaching the target. When these errors are increasing, this means I am going far from the target. So that will be an alarming situation. But currently it is good that error is decreasing. I am on the good direction. Okay, I am on the good path, or I am in the right direction. Now again the question comes, can I compute this EA percentage? Okay, I again go and look at the formula. Okay, I look at the formula. Okay, it says current approximation minus previous approximation. So it says you must have two approximations. Divide by the current approximation, multiply with 100%, you will be able to compute EA percentage. Okay, so do we have two approximations? At this point, do we have two approximations here? Do we have two approximations? Yes. Okay. So now one is 1.5 and one is 1. So which one is current and which one is previous? Remember that latest one is called the current one, and the previous one is, yes, 1.5 is the current one, and the previous should be just before that. The one before it is just 1. So I have to apply the formula in a very easy manner. I have current approximation 1.5. I have 1 as the previous approximation, divided by 1.5. Okay, I take the absolute value. I want positive error. Okay, I multiply with 100%. So this one I got 33.33%. Okay, so 3% error. Now look at the numbers. Okay, there are two important suggestions here. Okay, ET and EA are two different quantities. Even you can see from the numbers they are not the same. Okay, ET is computing accuracy, EA is computing the precision, that how close these two approximations are. Okay, so this is the precision measure, 33.3%. Okay, ideally what do we want is ET to be 0, EA to be 0. But here we are not waiting for EA to be 0. We are just waiting it to be less than 0.05, then we will stop. Okay, so if this error less than 0.05, so look here, this is the target I want to achieve, or this is the threshold I want to achieve. I currently have 33.3% error, which is far greater than 0.05. So I should continue, right? The moment this error is less than 0.05, we will stop. Okay, so how should I continue? The question is the same thing which was happening before in these two times where we do the same thing. What we did, basically I am doing the same thing again and again. I take a term number 1, I compute the true error, I compute the approximate error if possible. Then I take the second term, I compute the true error, I compute the approximate error. So what should be my next step? The next step is same. I take the third term, okay, compute the approximation. 1 plus 0.5, 0.5 square by 2, so this becomes 1.625. So I got another approximation. Okay, what should I do now? Same step. Apply, compute ET, compute EA, and then compare EA with 0.5. If it is EA greater than 0.05, repeat it. Okay, so here I will do the same thing. 1.64871 minus 1.625 divided by the true value. So what do you think, error will decrease or increase now? Decreasing of error means we are going towards the target. Okay, so what do you think, looking at the numbers? Are you going towards the target or you are going far from the target? Okay, by the way, I will also put the numerical value in the meantime here. Okay, the numerical value is 1.44%. Why the error decreased? The same reason, because I am getting closer to the target. Before my approximation was 1, then 1.5, then 1.625. Every time I do one calculation, I am getting closer to the true value, which is 1.648721. So that's why error is decreasing. Now what about this EA? Can we compute it? Okay. So now I need current approximation. Which one is current approximation? Now I have three approximations, 1, 2, and 3. The latest one is 1.625. So you remember that we said latest is called current approximation. So current approximation is 1.625. Previous one is just the one before it. It is 1.5 divided by 1.625. Okay, multiply with 100%, and then this value will determine should I continue or not. Okay, so this error is 7.69%, which definitely is greater than 0.05%. Okay, and we should continue with the next. We should repeat the next one. Okay, how should I repeat the next one? I add one more term, okay, and do the same thing. Every time I take one term, compute ET, compute EA, then compare EA with the threshold I have. Okay, if it is greater, I should continue doing the same thing. Okay, so let me show you the results of all this on the slides, which is because it is now time. I think to wrap up. Okay, so up till third time I did it. Okay, so these are all the results. Okay, I can see true value is decreasing, true error is decreasing. I can see approximate error is also going down. Okay, because this is my I'm getting accurate, I am getting precise. Okay, but not that much. But this error 7.69 is much greater than 0.05%. So that's why I added the fourth term, 1 plus x squared by 2 plus x3 by 3 factorial, which is 6. I get the fourth one. Okay, so don't concentrate on fifth and sixth. Let us concentrate on fourth one. I get this 1.645833. The true error I got is 0.175. The approximate error. So in this case, how this 1.27 was computed? It is current approximation is this number on the fourth count and the result of third count. Okay, so difference between the two divided by the 1.645833 give me 1.27, but this 1.27 again is greater than 0.05. So not until sixth count I was able to have an error less than 0.05%. So what I did, first term, second term, third term, fourth, fifth, and sixth term, I was able to have an error of 0.05%. Okay, and that is where I should stop. Okay, so now, by the way, I was telling it counting. By next time, we will also call it, and you will hear it many times. We call it iterations. So basically, I did 6 iterations. Okay, I am also typing it here in the chat box. The word is iterations, or iteration is one of the word. Okay, so iteration is a meaning of repeating, because I was repeating the same steps again and again. What are the steps? I take one term from the formula, I compute ET, I compute EA, and then I compare EA with the error threshold. Okay, if the error threshold has not been achieved, I continue, otherwise I stop. And this is how it happened that I continued at iteration number 1, 2, 3, 4, 5. But at 6th iteration, I came to know that EA is less than 0.05%, and that's why at 6th iteration we stopped. Okay, so this is already the time for the lecture. Okay, so we are already 2 minutes late. Okay. So, but from my side, I will stop here and keep the left, and the rest will be discussed in the next lecture. So, are there any questions before I leave? And we end the session. Before we end the session, do we have any questions? Okay. So, If there are questions, I'm here. Otherwise, then we will stop this session, and shall I see you in the next lecture then?